Hi, we are Team We Do 1.0, and this is our design project. Meet the members of We Do. From left to right, we have Arman Patel, Yatish Suresh Kumar, Philip Shin, and Nathan Lee. Transportation is a key aspect of a successful academic journey. Inadequate transportation leads to students being late to or missing classes, which negatively affects their grades. Our client, Purdue University, has given us the task of improving the safety of one aspect of campus transportation. Our stakeholders, the walking and biking community of Purdue, face serious danger whenever they traverse the bike lanes. Therefore, we have set out to implement innovative designs that increase bike lane safety and boast convenience. Our criteria consist of ease of installation, ease of use, aesthetics, and safety. Our main constraint is that the cost of ini- initi- initiating these designs should not exceed $5,000. The metrics we have used are public opinion, material cost per unit, and time for installation. Our first alternative prototype is an automated barrier designed specifically to be placed at high-risk, accident-prone intersections. The barriers are equipped with advanced automated sensors capable of detecting incoming bike or car traffic that poses a danger to pedestrians. When the sensor is activated, the barrier temporarily blocks pedestrian access. Additionally, the barrier effectively enhances overall traffic flow, reducing the likelihood of accidents and minimizing congestion caused by unpredictable pedestrian crossings. From our testing and research, however, we did not choose this prototype due to its low score in ease of installation and cost compared to the other prototypes in our weighted decision matrix. Our second alternative prototype is the installation of reflective bike lane barriers to specific bike lanes at equal intervals. This would improve biker vision, thereby reducing possibility of collisions during darkness. Through our research, we discovered that this prototype has the lowest installation time as it has a volume per unit of 1,029 square inches and the lowest cost at $105 per unit. However, it did not score highly in safety or ease of use, as it could cause injuries to pedestrians at night and requires headlights from bikes to function. Ultimately, we chose the bike barrier with light bumper since it scored the highest on the weighted decision matrix. Particularly, it scored well in number of incidents per year and the public rating, despite scoring lower in cost and number of materials. These barriers will border bike path on Stadium Avenue between Martin Jiske Drive and Northwestern Avenue at intervals of 16.33 feet. We observed that this area is a particularly dark stretch of bike path on campus and will require around 98 barriers lining the side of the path. They will contain an LED light fixture in order to optimally illuminate dark bike path and indicate the lane borders of the paths. In addition, the rounded and elevated shell will provide a physical cue to pedestrians to stay out of bike lanes, while also allowing for bikes to roll in and out of lanes without crashing into it. We found three different types of LEDs to use. Going with the lowest cost option, we would use LED 3, which produces 2,500 lumens. For our testing, we researched various different kinds of street lighting and compared the amount of lumens they produce to our choice of lights. Our data is drawn from Greenshine, a solar LED manufacturer, and LED My Place, a blog on all types of light sources. As you can see on the chart, the lumen count of our lights far exceeded the lumen of common lights such as path lights or floodlights, which tend to dimly illuminate sidewalks and driveways with only around 100 to 200 lumens. Although streetlights and residential streetlights have a greater amount of lumens than our LED, we took into account the fact that streetlights must illuminate streets from a distance above the street, while our bumper will illuminate bike lanes from the ground. Thus, we have found that our product will sufficiently increase visibility of bike lanes, even if we space them apart to reduce the amount of bumpers needed. However, even with these benefits, one limitation is that our bike lane barrier cannot account for accidents caused by human error or contribute to any safety during the day. Overall, our bike lane will allow for safer transportation of bikers at night by increasing visibility in bike lanes. It also increases the safety of pedestrians who may be at risk of collision with bikes in a poorly lit street. For our references, please scan the QR code provided. And thank you for listening.